All right, so looking at the day 2 notes, we did an example of this yesterday, so this is just more practice. The dy over dx just means that this is the derivative. It gives us f of 0 equals 6. So we want to find what our original function is, so we have to take the antiderivative. So we're going to take the antiderivative of 4x dx. So what's the antiderivative of 4x? If we add 1 to the exponent, what does that make our new exponent? 2. And then we would divide by 2. And then when we simplify this, we get 2x squared. What am I missing, though? Plus c. Don't forget, anytime you take the antiderivative, you need the plus c. So this would be n antiderivative. We want to find the antiderivative of our equation here. So we need to solve for c. So we're going to use that f of 0 equals 6 to help us solve for c. So f of 0 means that we plug 0 into the x. So 2 times 0 squared plus c. And what does f of 0 equal? 6. So I'm going to replace 6 with that f of 0. So when I simplify, I get 6 equals, this turns into 0, so 6 equals c. So then I take 6 and plug that in to my function here. So f of x equals 2x squared plus 6. Two and 3 are super similar. I'm going to let you guys do that on your own if you want extra practice. Let's take a look at 4. 4 is a little bit different because it gives us the second derivative now. So we want to find what our first derivative function is and our actual function. So let's take the antiderivative of x to the power of negative 3/2 dx. So when we add 1 to the exponent, I can add 2 over 2. So this gives me x to the power of negative 1/2. And then I divide by my new exponent, which is negative 1/2. So this is our first derivative here. What am I missing? Plus c. We can simplify this a little bit. When I divide by a fraction, you can think about it as keep, change, flip. So our first derivative would be negative 2x to the power of negative 1/2 plus c. We need to find what c is in our first derivative before we can do the antiderivative again and find our function. So let's solve for c here. So we're going to use this piece of information since this is our first derivative. So we're going to find f prime of 4. We're going to plug 4 into the x now, so negative 2 times 4 to the negative 1/2 power plus c. And f prime of 4 is equal to 2, so I'm going to plug that 2 in there. So 2 equals, I'm going to simplify this a little bit. When I have a negative exponent, put it in the denominator. So negative 2 over 4 to the 1/2 power. Plus c. What's 4 to the 1/2 power? Square root 4, but what's the square root of 4? 2. So negative 2 over 2 plus c. So 2 equals negative 1 plus c. So then we can add 1 to move it to the other side. C equals 3. So I'm going to take this and plug it into my function here. So our first derivative function is negative 2x to the power of negative 1/2 plus 3. Now we want to find our original functions. We have to do that again. So we're going to take the antiderivative of this now. So the antiderivative of negative 2x to the power of negative 1/2 plus 3 dx. So when we take our antiderivative, we're going to add 1 to the exponent. So I can add 2 over 2. This would be negative 2x to the power of 1/2 now. and divide by the new exponent. Plus, what's the antiderivative of 3? Three x, perfect. Plus c. If you want to call this c2, you can, just because it's not going to be the same c that we just solved for. You don't have to, just as long as you keep your work organized and you know we're finding a new c now. Let's simplify. F of x equals, when I keep change flip here, this would be negative 4, x to the 1/2 power, plus 3x plus c. So it gives us f of 0 equals 0. I'm using this piece of information now. So f of 0 means that I'm plugging 0 in, so negative 4 times 0 to the 1/2 power plus 3 times 0 plus c. And then f of 0 is 0. So when we solve for c, what do we get? 0. So we can plug 0 into our function here. That means our original function is, actually I'm going to plug it into the simplified one here. Negative 4 x to the 1/2 power, or the square root of x, plus 3x, plus 0. So we don't need the c in there anymore because we know c is 0. So number 1 says an evergreen nursery usually sells a certain shrub after 9 years of growth and shaping. The growth rate during those 9 years is approximated by dh over dt equals 1.5t plus 9. So this here, because it says dh over dt, this is our derivative, where t is the time in years and h is the height in centimeters. The seedlings are 19 centimeters tall when planted, so when t equals 0. Find the height after t years. So we want to find our original function. So that means we have to take the antiderivative of our function here. So of 1.5t plus 9 dt here, because t is our variable. So when we take the antiderivative, I'm going to change that 1.5 to a fraction, just because I know that I'm going to be dividing here, so it'll make it a little bit easier for us. So I'm going to call this 3/2. You could leave it as 1.5. Just be careful when you do the math. So when we take the antiderivative, we add 1 to our exponent, so our new exponent is going to be 2, and then we divide by our new exponent. So we divide by 2. Plus, what's the antiderivative of 9? What's our variable here? T, so 9t plus c. So this is h of t. We can simplify it a little bit. I've got a fraction in a fraction here, so when I keep change flip, this would be 3/4 t squared plus 9t plus c. Now we need to find what c is. Going back to the question, it says that the seedlings are 19 centimeters tall when planted. So when t equals 0, what does h equal? 19. The height would be 19. So if you wanted to think about this as a point, it'd be 0, 19, or h of 0 equals 19. So we're going to use this to help us find what c is. So h of 0 equals 3/4 times 0 squared plus 9 times 0 plus c. And h of 0 we said is 19. So what do we get for C? 19, awesome. So my function, h of t, would be 3/4 t squared plus 9t plus 19. Let's look at B. B says, how tall are the shrubs when they are sold? We're going back to the question, when are they sold? After 9 years. So what do you think I plug 9 into? T, because T is time. So we're looking for h of 9. So we just plug 9 into our T, into our height function here. So 3/4 times 9 squared plus 9 times 9 plus 19. You could use a calculator here, or if you wanted to just work it out, we should get 643 over 9, over 4. What would our unit be here? Centimeters, awesome. So after 9 years, they'd be 643 over 4 centimeters tall. Let's do number 2. So it says the rate of growth dp over dt of a population of bacteria is proportional to the square root of t, where p is the population size and t is the time in days as shown below. The initial size of the population is 300. After 1 day, the population has grown to 900. Estimate the population after 6 days. So let's find our function for the population. This is the derivative of it. So we want to find the antiderivative of k square root t dt. K is just a constant here. We're going to solve for k, but let's find our antiderivative first. So I want to change this to be an exponent to help us take our antiderivative, so I'm going to change it to the 1/2 power. Now when we take the antiderivative, we're going to add 1 to the exponent, so I'm going to add 2 over 2 here. So this gives me t to the 3/2 power, and then divide by our new exponent, which is 3/2, plus c. Let's simplify. I'm going to keep change flip. So we get 2/3, or I'll leave it as 2/3, k t to the 3/2 plus c. If you wanted to just leave the 3 in the denominator, you could call it 2k t to the 3/2 over 3. You could write it that way too. Doesn't really matter. So from here, we could solve for c. It says the initial size of the population is 300. So at the beginning, our size of our population is 300. Or we could say p of 0 equals 300. So we're going to plug 0 in for t and 300 in for p of 0. So when I plug this in, p of 0 equals 2/3 k times 0 to the 3/2 plus c, and p of 0 is 300. So what would I get for c? $300, awesome. This would be 0, so it cancels. 300 equals c. So let's plug that into our function. P of t equals 2/3 k t to the 3/2 plus 300. Now let's solve for k. So we're going to go back to our question. It says here, after 1 day, the population has grown to 900. So here we could call this P of 1 equals 900. So let's do the same thing we just did, but we're going to plug in 1 into our t and 900 into our P of 1. So P of 1 equals 2/3 k to the times 1 to the 3/2 plus 300. And then P of 1 is 900. So let's simplify from here. What should we do first to simplify? Subtract the 300, perfect. So 600 equals 2/3 k. What's 1 to the 3/2 power? 1, perfect. So that's just 1. Since it's multiplying to the k, we can just get rid of it. We don't have to put the 1 there. Now how could I get rid of the 2/3? Awesome, I can multiply the other side of my equation by the reciprocal, so 3/2. So it cancels there. Here you could do 600 times 3 and then divide it by 2, or if you wanted to divide it by 2 first and then multiply times 3. 600 divided by, so we get 900 equals k. So now let's plug that into our function here. So P of t equals 2/3 times 900 times t to the 3/2 plus 300. We can simplify this a little bit more. Let's multiply the 2/3 times 900. 900 divided by 3 would be 300, times 2 would be 600. So P times t. P of t equals 600 times t to the 3/2 plus 300. So this would be our equation for the population. Let's go back and see what the question's asking us for. It says, estimate the population after 6 days. What do you think I would do to find what the population is after 6 days? Awesome. Plug 6 into t. So P of 6 equals 600 times 6 to the 3/2 power plus 300. This, plug it into your calculator. It says round to the nearest whole number. So when you put it in the calculator, you should get 9,118. 9,118 what? What's this a population of? Bacteria. So we can just call it bacteria. All right, we've got one more. So use A of t equals negative 32 feet per second squared as the acceleration due to gravity. A ball is thrown vertically upwards from a height of 4 feet with an initial velocity of 58 feet per second. How high will the ball go? So one thing before we get started, we've talked about velocity and acceleration before, so kind of just to refresh our memories. Position is our starting function. The derivative of the position is the velocity, and the derivative of the velocity is the acceleration. So acceleration's like our second derivative of the position. So it's asking us about the height of a ball. Yeah. So we need to find the second antiderivative since we're given the acceleration. So starting with our acceleration function, let's find our antiderivative of negative 32, and this is with respect to time, so dt. What's the antiderivative of negative 32? It would be negative 32 t plus c. Perfect. Because our variable here is t. So this would be our velocity. Let's solve for c before we find our antiderivative again, because we can't find our antiderivative with just c as c. We need to figure out what it is. So let's go back to our question. It says a ball is thrown vertically upward with a height of 4 feet with an initial velocity of 58 feet per second. So the height of 4 feet is our starting position. So if we use p as our position function, I'll call it p sub o would be 4, or if you wanted to call it p of 0. And then our initial velocity, so you could call it VO or v of 0, would equal 58. So that is our initial velocity. So our starting velocity is 58. So let's plug that in. We're going to use that to help us find c. So v of 0 equals negative 32 times 0 plus c. And v of 0 we said was 58. So what does c equal? 58, awesome. So our velocity equation would be negative 32t plus 58. Now we want to find the antiderivative of this to find our position equation. So we're going to find the antiderivative of negative 32t plus 58 dt. So starting with negative 32t, we add 1 to the exponent. So this would be negative 32t squared, and then divide by our new exponent, so divided by 2. Plus, what's the antiderivative of 58? (58t) plus c. So this is, I'll call it our position with p. Sometimes the position function is called s. I think most of the time when we did these it used s, but we'll just call it p. When we simplify this, negative 32 over 2 would be negative 16. So I'm going to simplify here. So this would be negative 16t squared. Let's find what our c is in our position function. So we got to solve for c now. What do you think would help us solve for c? Awesome. So our ball was thrown vertically upward from a height of 4. So our starting height was 4, the starting position. So that p of 0 equals 4. So p of 0 equals, I'm going to plug in 0 into all of my t's. So negative 16 times 0 squared plus 58 times 0 plus c. And p of 0 is 4. So what does c equal? 4. Awesome. So our position function, when I plug that in, I'll call it p of t equals negative 16t squared plus 58t plus 4. So this is kind of step 1. If you can find this, you're off to a pretty good start. Now let's go back and see what the question's asking us for. What does the question ask? How high will the ball go? Let's think about the equation that we have here. What would the shape of the graph of this equation go? What would it be? A parabola. Awesome. A parabola that opens up or opens down? A parabola that opens down because our leading coefficient's negative. So our graph would kind of look like this, where it'd be a parabola. We're talking about how high our ball goes. So the highest point on our graph, which would be a maximum, how would we find the maximum? You can do that. Negative b over 2a to find kind of your vertex. How else did we talk about in chapter 5 how to find the maximum? Find the critical numbers. So you could do it that way too. Let's find our critical numbers. What would we use to find the critical numbers? So in the last test that we took, how would we find the critical numbers given our function here? What would we do? Find the first derivative. We already have the first derivative. What's the first derivative of the position? The velocity. So that would be our equation here. What do I do with the first derivative? Set it equal to 0. So when we set it equal to 0, this would be negative 32t equals negative 58. Divide by negative 32. So t equals, when you put this in the calculator, you'll get 1.8125. Now this is the time. So that's kind of like our x value on the graph here. So we reach our maximum in 1.8 seconds, I think is what it uses here. Yeah, seconds. But how do we find the height? We're looking for the y value. Plug it into what? The position function. We plug it into our original function, which our original was the second antiderivative here, but we'd plug it into our position function. So I'm going to plug that into the t's. So p of 1.8125, when you plug it in the calculator, this would be negative 16 times 1.8125 squared plus 58 times 1.8125 plus 4. So we should get 56.56 when we round to 2 decimal places. And what unit are we talking about? Feet.